Hyperbolas are complicated, so let's talk first about characterizing it as either a vertical or horizontal. Now this one, you can tell I've given a hint right here. This is a vertical hyperbola, this equation right here. Because if you notice in the equation, I've got a positive y squared. And you see, when you've got a positive y squared in standard form, that means it's a vertical hyperbola. So let's go ahead and we'll just take a note of that. Plus y equals vertical. And now let's try to get this into standard form by bringing all the y's to one side, and we're going to group those together. So we've got 4y squared plus 8y, and then I have this minus 9x squared minus 54x. I'm going to bring my 113 over to the right side for use later when I complete the square. Now I pull out a GCF from the y's, and this gives me y squared plus, looks like 2y, and then I have 9 as the GCF on x squared, negative 9, and that'll give me, looks like plus 6x equals 113. Okay, so now let's write that again, and this time I want to write them using perfect squares. I'm going to have to do a little monkey business here. I'm going to add some number to the y's, and likewise I'm going to add a number to the x's. And I just have to make sure that I add the same thing to both sides. So let's see. To make this one a perfect square, looks like I'm going to be adding 1 right there. Okay, that way it's going to be y plus 1 times y plus 1. So this will be plus 4 times 1. Okay, let's try the same trick for the x's. This one looks like it needs to be plus 9. Okay, so this will be plus, excuse me, that'll be a minus 9 times 9 to each side. And now take a look at what happens once I factor these out. It'll make more sense why I chose those numbers. Y plus 1 squared, and then I have minus 9, and this perfect square is going to be x, looks like plus 3 squared. Okay, on this side I still have 113 plus 4 minus 81. Okay, so what do we get there? Well, that's going to be some math. 113, 19, 13. Nope, calculator time. Let's see. Equals 113 plus 4 minus 81. It's 36. Okay. 36. So now the next step is you want to have a 1 on the right side. So we need to do that. We need to divide by that 36 over there, right? I'm going to do divide by 36 on each side. So when you do that, what you get is this divided by 36, this divided by 36, this divided by 36. And look what we end up with. Y plus 1 squared over 9 minus x plus 3 squared. Okay, that's a 3. Sorry about this messy 3 right there. This is x plus 3 squared. This one's divided by 4 equals 1. This is your standard form for the hyperbola. So that's what goes right here. Now we can learn all sorts of interesting things about the hyperbola from that equation. For one thing, the center, remember h comma k, this is located at, you look at the x value, that's going to be negative 3, and the y value, it's going to be negative 1. Okay, let me find my way back to my program here. Okay, so negative 3, negative 1. And what else do we have here? The vertices. Well, to find the vertices, you need to pay attention to what we're dividing by here. Okay, so in this case, with the y's, I'm dividing by 9, and the x's, I'm dividing by 4. So we think, okay, that means b squared equals 9, therefore b equals 3. And a squared equals 4, that means a equals 2. Now, because it's a vertical hyperbola, that means you're going up and down from the center by the amount in the y direction. So this is going to be negative 3, comma, and we're going up by b right here. So we're going up from negative 1, that makes 2. And we're going down from negative 1, that makes negative 4. Okay, there's your vertices. And because it's a vertical hyperbola, again, this is the shape I'm talking about here, something that looks like this. So the vertices are going to be up and down in the case of a vertical parabola. See, we got them right here. And the co-vertices go right and left. There's a co-vertice, and over here is a co-vertices, these blue dots. So that means I'm going left and right by the amount dictated in the x part of the equation, this part right here. Okay, so that's going to be 2 to the left and right. So from the center, that's going to put me at -5 if I go to the left, and at -1 if I go to the right. See, the y values don't change, but the x values do in this case. Now, the foci, in the case of a vertical hyperbola, are located up here somewhere. So there's a focus, and here's a focus down here. I don't know if those are exactly in the right place, but that's the idea. So there's a foci, there's a foci. So we need to go up and down from the center because it's a vertical hyperbola. Now, the amount you go up and down is c. If you remember what c is, c squared equals a squared plus b squared. In a hyperbola, the distance from the center to the focus looks like a Pythagorean theorem. And there's reasons for that. We discussed those in class. But let's just calculate what that's going to be for us. Now, a squared, in this case, is 4. B squared is 9. So that's 13. So that means c equals radical 13. So I'm going up and down from the center by radical 13. Well, the center is -3, -1. So this is going to be -3, -1 minus radical 13. And the next one will be -3, -1 plus radical 13. Okay, there's my foci. The equations of the asymptote is another extra complication with hyperbola. Notice these lines right here. And I want to draw something that should be very helpful as you're thinking about these. Imagine your vertices and co-vertices form a box. This is sometimes called the viewing window of the hyperbola. There's all sorts of names for it, but if you imagine that box right there, you can see it's actually not hard to figure out the slope of these asymptotes. They simply go up by the vertice and over to the right by the co-vertice. Or in other words, m equals b over a. Right? B being the y distance. For us, that was 3. A being the x distance. For us, that was 2. So I've got equations that are going to have a slope of 3/2. And we have to figure out what the full equation is going to be by using this center point right here. Okay? And in our case, that was -3, -1. So I'm going to say y equals mx plus b. And now we plug in numbers. So -1 is the y location. 3/2 is the slope. And the x direction is, this is -3 right here. So I need to figure out what b is, the y-intercept. And now what do we get? -1 equals -9/2 plus b. And we just add 9/2 to each side. So over here we've got -2/2 plus 9/2 equals b. That means b in this first equation is going to be 7/2. So it takes a little bit. It does. My first equation, this one right here, for that asymptote, I'm going to call this y1. And that y1 equals 3/2 x plus 7/2. Okay, so that's how you calculate one of the asymptotes. The way you calculate the other one is exactly the same, except now, let's put this one in red. Now we're going down. That is the only difference. So we're going to say m equals -3/2 because it's going down instead of up. And you plug everything back in. You say the y location is -1, -3/2 times the x location of the center, that's -3, plus b. Solve this, and you're going to get the b value of this one. And I'm going to skip some stuff. Okay, right? We're going to skip the same sort of steps from above. And what you'll get, if you're checking your work here, it's going to be -3/2 x. That's the slope of the downward asymptote. And in this case, we're going to have a -11/2. Okay, that'll be your second asymptote, y2.